We're going to finish up section 4, Basic Rules of Algebra, here at page 5 on the notes, by practicing some translation. And we're going to then, we're just creating expressions, so no equal sign, and then we're going to simplify. So we're using, we're continuing to practice our translation skills. And then we're applying what we learned in this section so that we can simplify them. So that it's like there's two answers. We have the translation part of the answer and then the simplified version of it. So we'll apply our skills of reading, breathing deeply to get some oxygen and some calmness into our heads, and then read it a second time, keep the goal in mind. It's an expression, no equal sign. We're just going to translate the words into algebra. Then we look for keywords that allow us to change it into the operations and the numbers and the variables. And we do a look back to make sure that what we've written makes sense with the original equation. And once we've finished that translation, we will simplify. So let's read this first one together. The product of 5 and a number, which is then subtracted from the product of 11 and a number. Deep breath. Let's try that again. Product of 5 and a number, which is then subtracted from the product of 11 and a number. Notice I included a pause here with the comma so that I know I've got some separated things here. That comma sets it apart a little bit. So let's highlight some key words here. The goal, of course, is we want an algebraic expression, so no equal sign here. The product of 5 and a number, so we're multiplying 5 and a number together here. So that's a key thing here. We're going to multiply. We love the of and because it tells us the two things we're going to multiply. We don't know the numbers, so it'll be x. Which is then subtracted from. So it's then subtracted from what? And that subtracted from is very key. Again, order matters here. So if you can't come up with, if you haven't memorized what subtracted from means, it means this first item being taken away from the second item. So it's second item minus the first. That's what subtracted from means. If you can't remember that, and that's okay, we can't remember everything in life, but we can have the tools to recreate it for ourselves, to remind ourselves. So use something simple like try to translate the phrase 3 subtracted from 5. And then write that in the order that gets you the answer you expect. 3 subtracted from 5, 3 taken away from 5. We should expect an answer of 2. So what gives us an answer of 2? 3 minus 5 or 5 minus 3? The 5 minus 3 gives us the answer we expect. So that means 3 subtracted from 5 is translated 5 minus 3. So the product subtracted from another product means this second one is going to be written first. So the subtracted from item is going to be at the front here. And then what is it subtracted from another product? So again, we're going to multiply, and we have that lovely of and combination that tells us we're multiplying 11 and a number. So that same number x there. So we've got a product minus another product. That's the basic idea. We've got a product subtracted from another product, but which one is it? Well, it's the first one subtracted from the second, so it's the second minus the first. It's the product of 11 and a number minus the product of 5 and a number here. So those are what's being subtracted. So finish the translation here. Product multiplying, that's 11 times x, minus product multiplying 5 and a number, that's going to be 5 times x. So our expression that we've translated here is going to be 11x minus 5x. And you'll see the two answers in the back of the book. And the simplified version, we're looking to get rid of any parentheses, distribute as needed, multiplication over addition, and then combine like terms. In this case, we have like terms because we have two x's that are identical, same variable, same exponent. We have 11 of them minus another 5 of them. That leaves 6x. Let's try number 74 together. Let's read it. 9 times the sum of 3 and a number. Deep breath. Read it again. 9 times the sum of 3 and a number. I see two things here. My same goal, algebraic expression, no equal sign. And then once we get that expression, we're going to simplify. So I'm looking at 9 times, obviously we're multiplying here. Sum, that tells me I'm going to add, and there's my lovely of and I'm going to be adding 3 and a number. So it's 9 times the sum. So it's going to be 9 times the sum, whatever that sum is. Well, they tell us that the sum is 3. The sum is 3 and a number. So it's going to be 9 times 3 plus x, or you can write that as 9 times 3 plus x. Order doesn't matter with addition, so you can write that as x plus 3, and that would be fine too. So there's our expression. Took up just a little bit too much space there, so I'm going to need to do my simplifying over here. In fact, I'll come over here to simplify. I've got my 9 times our 3 plus x, and again, simplify for our purposes means we're looking for 2 things. One, to get rid of any parentheses that we can. So in this case, we have the chance to do that by distributing the multiplication over the division, which means we're going to multiply that 9 by both terms that are in the parentheses, and then combining any like terms. So in this case, it's going to be 9 times 3 plus 9 times x. That plus just comes straight down here. The 9 gets multiplied by both pieces, the 3 and the x. 9 times 3 is 27 plus 9x. Or if it feels more right to you, one's not more right than the other, but if you feel like you want to put that x piece first, that's okay. That actually is going to be very helpful as we get towards linear equations in Chapter 4 at the end of the term. Alright, so we'll do the next video will be the try problem at the bottom of the page.